Welcome to the channel. The purpose is to facilitate students in learning physics at their convenience. Students, let us start our today's topic, that is projectile. Very interesting topic. Students, first we define what is projectile. Any object that we throw in air making certain angle with horizontal, and it moves only under the action of gravity without any deriving force is called projectile. Students, a projectile motion is an example of motion in two dimensions. When we kick a ball, when we hit a ball, or when we fire a bullet from the surface of earth making certain angle with the horizontal, all these are the examples of projectile motion. Here we neglect the air resistance. Students, to get the equations for different terms that we use in case of projectile, let us consider an object is thrown or is fired making certain angle theta with horizontal, and it is fired with some initial velocity, we call it vi. Due to action of gravity, instead of moving straight, it follows a semicircular path. This path is called trajectory of projectile. Students, as I told you, it is an example of motion in two dimensions. So we will apply the equations of motion separately along horizontal or x-axis and along vertical or y-axis. Now in this case, we have assumed that there is no deriving force, and the only force that acts on this object is the force of gravity, and we neglected the air resistance. Since there is no force along x-axis, there is no acceleration along x-axis, means ax equals to 0. Along x-axis, the projectile moves with constant velocity, and along y-axis, the acceleration is acceleration due to gravity. So we say that along vertical, it moves with constant acceleration, and along horizontal, it moves with constant velocity. Now we apply the equations of motion separately along x-axis and along y-axis. After some time of its firing, what will be the value of its velocity? Let v is the velocity of the projectile during its flight and any time. Since it is changing its direction at every point, let phi is the angle that this velocity is making with horizontal at that time. Here the velocity has two components, along x-axis and along y-axis, horizontal component and vertical component. So we apply first equation of motion to find the value of the velocity after some time, means final velocity along x-axis and final velocity along y-axis. So applying first equation, students, we will apply equations of motion separately along x-axis and y-axis. Applying first equation of motion along x-axis, the initial velocity along x-axis is equals to vi cos theta, and the final velocity along x-axis vfx is equals to vi cos theta plus axt. Here we applied first equation of motion. Since there is no acceleration along x-axis, putting ax equals to 0, what will be vfx? Vfx is equal to vi cos theta. That I told you, along x-axis it moves with constant velocity. Initial velocity along x-axis is the same as the final velocity along x-axis, that is vi cos theta. Now applying the equations of motion along vertical. VIY initial velocity along vertical equals to VI sin theta, and final velocity along vertical equals to VFY equals to VI sin theta minus GT, because the projectile is vertically moving against the gravity, so I inserted negative G. G is the acceleration due to gravity. Now it is the equation for final velocity along vertical. Now students, the magnitude of the velocity at any time, here V, what will be V? That is equals to Vx square plus Vy square. Final velocity along x-axis, square of the final velocity along x-axis, and square of the final velocity along y-axis under root. Inserting the value of Vx and Vy, we get V equals to Vi cos theta whole square plus Vi sin theta minus Gt whole square. Students, this is the equation that we use to find the value of velocity, magnitude of the velocity of the projectile at any time during its flight. Now, what will be the direction? As I told you, if phi is the angle that velocity is making, then we use this equation. Phi equals to tangent inverse Vy by Vx, putting the value of Vy and Vx. Here is the equation that gives us the direction of velocity at any time. That is, phi equals to tangent inverse Vi sin theta minus Gt over Vi cos theta. It is the equation that we use to find the direction of velocity during the motion of projectile. Now students, another term that we use in context of projectile is maximum height. What is maximum height? The maximum vertical distance covered by projectile is called maximum height. Look at this diagram. H is the maximum height of projectile. To find mathematical equation for maximum height, we apply third equation of motion along vertical. That is 2AYH equals to VFY square minus VIY square. Now inserting the value of AI, VFY, you know, at maximum height the vertical component of velocity becomes 0. So putting these values, we get minus 2GH equals to 0 square minus Vi square sin square theta. Rearranging this equation for H, we get, you know, the negative sign will be cancelled and we get H equals to Vi square sin square theta over 2G. Students, it is the equation to find the maximum height of projectile. Look, this maximum height depends upon two factors. What is the launching velocity Vi, and what is the angle at which the projectile is fired. Next term that we use here is time of flight. How much time the projectile remains airborne, or how much time it remains in air. To find the time of flight of projectile, we use second equation of motion along vertical. Students, the distance, vertical distance moved during its whole flight is equals to VIY into T plus half AY T square. We used second equation. Now after completing its flight, it returns to the level from where it was fired. So vertical distance traveled by the projectile is 0. So putting values, 0 equals to Vi sin theta into T minus half Gt square. Students, rearranging this equation, taking half Gt square on the other side, T will be cancelled with the T and we get the time of flight T equals to 2, taking 2 on the other side, G on the other side, 2 Vi sin theta over G. It is the equation for total time of flight. From this equation, we can also calculate time to reach the summit height. Time to reach the reach the time taken by the projectile to reach the maximum height, we just divide this equation by 2, and that will be vi sine theta over g. That is called time to reach the summit height. And the next is range of projectile. What is range? The maximum horizontal distance covered by the projectile. Maximum distance that projectile travels on returning to the same level from which it was fired is called range of projectile. We can find the range by multiplying the time of flight with horizontal component of velocity, or using this equation, second equation of motion along x-axis. S is equal to vix into t plus half ax t square. Since there is no acceleration along horizontal, putting ax equals to 0, this second term will become 0, and in the first term we will insert the value of vix and time of flight. So putting vi cos theta into 2 vi sin theta over g, the value of time of flight, and this term I told you will become 0. Now the equation becomes r equals to 2, multiplying the brackets with each other, 2 vi square sin theta cos theta over g. Students, you know that 2 sin theta cos theta can be written as sin 2 theta. So we get r is equals to vi square sin 2 theta over g. It is equation for range of projectile. This equation shows that range will be maximum when value of sin 2 theta equals to 1, or 2 theta equals to 90, or theta equals to 45 degree. When we fire a projectile at 45 degree for a given value of velocity, it will attain maximum range. Now to summarize all these things, there are few steps to remember. What are these points to remember? Number 1, projectile motion is a motion in 2 dimensions. Number 2, in this motion we neglected air resistance. Air resistance is neglected while deriving equations for projectile motion. Only gravity acts. That is the motion only under the action of gravity. Horizontal acceleration is 0 since there is no horizontal force acting on it. And finally, the range of the projectile is maximum for an angle of 45 degree for a given speed. Students, these are the important informations regarding projectile motion. I hope it is clear. Students, thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.